Today you're doing division property of exponents. So get that down there, and actually going to uncover one more piece here for you. A quick note, things that we've talked about. Zoom out there. There you go.
Bless you.
Please. So remember, all exponents are positive, or when all exponents are positive, that's when your expression is in simplest form. So we're kind of to the last section here. So anytime you see a negative exponent, you need to think that's not simplified, unless, there's one exception to that, unless you're in scientific notation. Scientific notation, we can keep the negative exponent. Any other time, you have to get rid of that negative exponent, make it positive, by moving it in that fraction. Okay? So we're going to start out with, actually, I'm not going to make you read about that. I'll put that up here. But top of page 401, there we go. Page 401 gives you this example. I want you to study that example and try to work with your groupies to simplify numbers 1, A, B, C, D, E. Here we go. To begin with here, we're going to start out with person number 11, which happens to be Alex. She's not here. Sorry. Person number 20, Emily. Emily M. What do you got?
I got 5 to the 4.
You got 5 to the 4. Okay.
No.
So how did you do that?
I put 7 5s on top.
7 5s on top. Is that because it was 5 to the 7th, right?
Yeah.
Okay. That's only 6. Here, go one more. All right?
And then I put 3 5s on the bottom.
Put 3 5s on the bottom. Okay. It's because 5 to the 3rd. All right.
And then I crossed out 3 on top.
So you canceled out 3 on top. And I think this is supposed to be a 5, not a 3. That's my thing. Okay?
And then I crossed out 3 on the bottom.
Good. So this one cancels that one, that one, that one, that one, that one. Okay.
And then I counted the 5s that are left.
Man, that's a great explanation. There you go, 5 to the 4th. That's exactly how you do it, yeah. Now, the shortcut, let's see if we've got someone that can give us a shortcut. Person number 5. Caleb, what do you got?
For number D, I subtracted 8 from 12.
Okay, subtract 8 from 12, so you got 5 to the 8, or the 12 minus 8, which is 5 to the 4th. Hey, that's the same answer. Cool. All right. Person number, it's 20 again. That's only M again. What do you got? What's this one?
5 to the 4th.
Yeah, 5 to the 8 minus 4, which is 5 to the 4th. All right. Are they all 5 to the 4th? No. No? Okay.
No.
What's letter D? Amanda, that's you.
Letter D?
Yeah.
I got 4.
You got 4?
Yeah.
So just 4?
No, like 5 to the 4th.
Oh, like 5 to the 4th. Okay. Yeah. 5 to the 4th. 5 to the 5 minus 1. Okay. Good? All right. Well, they all look 5 to the 4th. How about person number 18, Emily L?
For E,
Yeah.
I got 1 over 5 to the 3rd.
You got 1 over 5 to the 3rd. Now, how'd you get that?
Because when you subtract 5 from 8, it's negative. It's 5 to negative 3. So you have to make fractions.
Okay, good job. So we make that fraction and switch it, so that becomes 1 over 5 to the 3rd. Hey, well done. So we almost could say the pattern was 5 to the 4th until we got to this one. What is the pattern they're talking about? Volunteer. Pattern they're talking about here. What are you doing every time the same in that problem? First hand, yeah.
Subtracting the exponent.
Yeah, you're subtracting the exponent. So one of the deals we're dealing with, if we're saying, say, like we have a to the m power over a to the n power, that's equal to, any volunteers? It's a tough one. We're trying to standardize it there. A to the m over a to the n. What's our base going to be? It's going to be a. You want to raise your hand and tell me what my power is going to be?
Minus n.
Yeah, m minus n. You guys got to be quick on the draw on the raise of the hand. Good. A to the m minus n. Well done. You're just subtracting the two. All right. Nice work. Any questions? Okay. That being said, I want you to tell your neighbor. You don't have to write all these down. Just tell your neighbors. You don't have to use your calculator either. Just tell your neighbors what all the boxes are going to be.
So good.
Okay, person number 9, Brina. What do you got? 5 to the 7th. Yeah, 9 minus 2, 5 to the 7th. Well done, Brina. All right. Yeah, Amanda. 2 to the 1st. Good job. And we don't have 28. Marley.
Miss Marley. What's that for next?
What do you think? What are you doing here to get that?
2 minus 5.
Yeah, 2 minus 5. What is that?
-3.
-3. Well done. Yep. And now they just want it like this, but normally we would switch this. Anyone want to raise their hand and tell me? Kelly?
1 over 3 to the 3rd.
1 over 3 to the 3rd. Hey, I have good peripheral vision, man. I saw it. 1 over 3 to the 3rd. Good. This works. All right. And number 8, Kylie.
The
Yep. I'm sorry. Letter D. Yeah.
5 to the 1st or 5.
5 to the 1st or just 5. Yeah. Good work. Okay. Well done. I want everyone to take a look at example. Okay. Can I have your attention back up here? You guys have been working on the top row. Many of you finished the top row. How many have moved down to the second row? How many are on the third row? Hey, whether you're on the third row or not, I want everyone to try number 9 right now. This is a common mistake right here. So let's take a look at 9. Everyone give it a shot. All right, do we have anyone that can explain it to me? Go ahead.
My best shot. Okay, so I put 6 to the 3rd on the bottom,
6 to the 3rd on the bottom.
and then 6 to the 5th on the top.
Okay, so you just moved them.
Yay.
Okay, did anyone else do it like that? You moved them like that to begin with?
That's it.
Okay, so what did you do from there?
And then I just subtracted the 3 from 5 and got 6 to the 2nd.
Okay, 6 to the 5 minus 3 is 6 to the 2nd. Okay, no one else did that? Okay, so do I have another person that can explain it? Go ahead, Dan.
If you subtract the negatives, it's just like they become so.
Okay, so another way to do it is to say 6 to the what? How about 6 to the negative 3rd? Minus? -5. Okay, anyone do it like that? 6 to the negative 3rd minus -5. What happens right here? Dylan? That becomes plus. Okay, so that gives us 6 to the 2nd. That's another way to do it, right? Oops. Make sure I stay on the screen there. That gives us our 6 to the 2nd. Okay? Any questions there? All right, I want everyone to try this set right here. Whoa. It's helpful if I get them on the screen. There we go. Simplify each expression. Make sure you're only using positive exponents. All right, give it a go. Work with your. Hey, can I have your attention back up here? Thank you. Guys back there, pay attention. Ethan, you're up. Letter A. 1 over b to the 5th. So you did b to the 4 minus 9. And that's b to the negative 5th? Is that how you did it? Okay. And that gives you, we need to use positive exponents, so we put that over 1, we bring that down. So that gives us 1 over b to the 5th. The other way to think about that, when you have it like this, another way to think about it is when you look at b to the fourth and b to the ninth, if you think back to what we did at the very beginning where we wrote that out expanded, b times b times b times b over b times b times b times b times b times b times b. Is that 9? That's not 9. Times b. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You look at it like that, if you start canceling, oops, I missed. That gives me a 1 left on top. When everything cancels out, you're left with 1 and b to the fifth on bottom. So 1 over b to the fifth. So that's another way to think about it. I like to look at this. I know it's subtraction, but when I look at it and I go, where do I have more b's? Top or bottom? I have more on bottom. I have 5 more on bottom. That's my answer. So when I look at this, I like to say, I know it's z to the 10 minus 5, which is z to the fifth. Or you could say, where do I have more z's? Top or bottom? Top or bottom? Bottom? Nope. Top. I have 5 more on top. Okay? So where do I have more a's? Top or bottom? Bottom. How many more?
2.
A squared. Where do I have more b's? Top or bottom? Bottom. How many more?
3.
Nope. 2 more. And what's on top? 1. Okay? How many got those 3 correct? Well done. Okay. Well, let's try letter D. Person number 8. Number 8, we got Kylie.
I got n over m to the fourth.
You got n over m to the fourth. Okay. All right, anyone want to walk me through how to do that? Volunteer? Go ahead, Kylie. Yeah.
Negative 1 minus 3 is negative 4. And so it has to be the denominator because your exponent has to be positive. And 2 minus 1 is 1. And so that's m to the first. Or just 1. And since that's positive, that becomes the numerator. And then m to the fourth.
Okay, so good. We've got this. We do the 2 minus 1. That gives us 1, and so that's n to the first. And we got m to the negative first minus 3. So negative 1 minus 3 is negative 4. So we write it like that. N to the first times m to the negative fourth. And this part has to go down. So we get n over m to the fourth. We don't have to put the 1 for that. Good work. Questions on it? Got a volunteer for letter E? Zach? What do you got?
XZ7 over Y3.
Good. So let's check it out. So xz to the 7th over y to the 3rd. So I'm looking at it. I've got more x's on top by 1. I got 1 more on top. 2 minus 1 is 1. I got 1 minus negative 4, which gives me, or 1 minus 4, excuse me, which is negative 4, or negative 3. So I have 3 more y's on bottom. And then here, you could think of this as going up, or you could say z to the 4th minus negative 3, which is z to the 7th. Good work. How many got that? Okay, questions on them? I want everyone to finish example 1 right now, please. Okay? Spend about 3 or 4 more minutes on it. Ask questions as I'm coming. All right, I need your attention back up here. Hey, talking to a few of you, there are a couple concerns. So let's give me a few problems here to work through. Give me one in example 1. Go ahead.
13.
Number 13. So 13, this one's kind of a mess. This is a good one to work through. So if you're struggling on it, pay attention. If you didn't struggle and you just want to know if you got it right, double check it here. Here's a quick way to do it. You're looking at it like this. Just match up your common bases. So a to the 4th and a to the 8th. Okay, a to the 4th and a to the 8th. If we look at that, that's just a to the 4 minus 8. A to the 4 minus 8 is a to the negative 4. Okay? Now, if I'm putting my complete answer right here, a negative exponent goes on the bottom, and it becomes positive. So we write that part right like that. Okay? And now we look at the b's. We have b to the negative 7 minus 3. What's that? You guys get?
10.
Yeah, that's negative 10, right? So that's b to the negative 10, which it's negative. Where does it go? Top or bottom? Bottom, and becomes positive. Okay? And then we have c to the first and c to the negative 6. So c to the 1 minus negative 6. So don't forget, you're subtracting what's on the bottom. So that becomes, the double negative makes plus, so it becomes c to the 7. Positive goes on top. That's my answer. So if you treat each part as an individual problem, it makes it a little easier, I found, working with you guys there. How many got that right? Okay. Ready to move on? Okay, I want to try another set here. Let's take a look. I want to work on number 17 together. So take a look at 17. I want everyone to do what you think you should right there. Some of you have already done it. That's fine. But if you haven't, go ahead and give it a shot. It says simplify each expression. Give your answer in scientific notation. Try number 17. All right. Volunteer. Go ahead, Dan.
So, divide the 5 by 2 for 5 equals 2.
Okay, divide those. You get 2.
Times 10 to the second power is subtract 6.
Okay, so subtract 6 from 4 and you get 2 times 10 to the second. Okay, very good. Nice work, Dan. Hey, volunteer to tell me why that's in scientific notation. Go ahead, KK.
Between 1 and 10.
Yeah, this number's between 1 and 10.
Question.
Okay?
Why do you divide? Is that just subtraction? I mean,
Well, you divide numbers. Like when they're numbers, you divide. When they're powers, you subtract.
oh, okay.
Yep. All right, very good. Any questions? All right. Hey, I want to drop down to example 3. We're going to try a few of those there. Okay? So, in order to do that, I want you to work with your groupies on this statement here. Put it in your notes. Number 10. All right. Here we go. Austin, your number came up. What goes here, Austin? 8? How'd you get 8? 2 times 4. Does this mean 2 times 4? Four goes here? No, not quite. Kelly, what do you got?
You do 4 squared, which is 16.
Good, yeah. Austin, you're on the right track. It's just not 4 times 2. It's 4 times 4. Or 16. All right. Well done. Okay, we got the 16. That's really hard to read right there. Let me write it above it there. So this would be 16. Okay. And then 16a to the?
6.
A to the 6. Wow. All right.
Someone's excited over there.
Yeah.
We're gonna get
Live it out.
Yeah, I know, but hey. Okay, and person number 22. Ethan. What goes here? What's that? Yeah, second. Okay, so really we're bringing this into each part, right? So it has to go to every single piece in here. So 4 squared, a cubed squared, which is a to the 6th, and then b squared. Okay, so we get 16, a to the 6th, b over b squared. All right. Okay, person number 7. Charles isn't here.
Wait, that's it?
Number 18. That's it. Yeah. Nothing left to do. All powers are positive. Yep. All right, person 18, Emily L. What do we do on this one? Negative 3 plus 8. Good. And if so, this one and this one, they're on the same level. So when we're on the same level, we add. Then different level, we have to subtract. So negative 3 plus 8, that's a negative 3, minus 2 is 3. X to the third. Well done. Any questions there? All right. Here's what we got. Let's take a look at these problems here. I want you to try letter A and B. A and B.
Talk about brain fried. Eat that.
Yeah, everyone's attention back up here. Kalina, you get letter A. What do we do first here?
You times the 2 to the square root of 4.
Okay, so you raise 2 to the power of 4.
Yeah, and you get 16.
Okay?
And then
Hey, you guys talking back there, be done. 2 to the 4th.
and then you times 5 to the power of 4 too.
Okay? So m times 5, or 5 to the power of 4.
And you get 625.
Okay, let's pause right there. So did you raise 5 to the power of 4?
Oh yeah.
So it'd actually be 5 times 4.
Oh.
Yeah. So
M to the 20th power.
m to the 20th. So on top we get 16 m to the 20th. All right, very good. We're going to pause there. And person number 15, that's Kelly.
Okay, and then do 4 times 2,
Yep.
and then it's m to the 8.
Okay. So m to the 4 times 2, which is m to the 8. And then from there, what do we do? Got one step left. Anya's got subtract here, so what do we get? 16 m to the 12.
M to the 12.
Yep. Because 20 minus 8.
Whoa. So why didn't we subtract the exponents on the last one?
We did.
I'm really confused. Okay, why don't I'm confused.
So, yeah, they have to be the same letter to subtract your exponent. Have to be the same base.
Okay. I feel like you just came out of the. Never mind.
So you're talking about on number 13.
And no.
Okay.
No, the one we did before that. We didn't subtract.
I think that was 13.
Okay, I got m to the 8. I was asking how you got the other one.
So did you get the m to the 8th here? So you got to here.
Yeah.
So from here, these are the same base. So you got to subtract the exponents.
Okay.
Yep. Okay, hey, we got to be done there. Your assignment is to finish up the mix or the example side, excuse me. Okay? Yep, so we have